what is a surd? So a surd is basically a root of a number or an irrational number. So when you have got a root of 2, you can't find the exact root of 2, the root of 3, the root of 5, the root of 7. You can't find their exact values. These are called surds. So you can simplify surds, and you can add surds, you can multiply surds, you can divide surds. So after this lesson, you should be able to simplify, add, subtract, and multiply, divide surds. All right. Now, firstly, how do you get to simplify surds? Let's say you've been given the square root of 24. You want to express this surd in the simplest form. What you do is this: when you want to express a surd in the simplest form, look for square numbers. What are square numbers? If you write 1, 2, 3, 4, 5, 6, if you get to square these numbers, those numbers that you are going to get are called square numbers. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared 25, 6 squared 36. So these numbers you can see here are called square numbers. So what we are going to do is this 24, start dividing by the smallest square number that you know. Well, the smallest square number is a 1, but don't divide by 1, because you know that 1 divided by anything is that same thing. So go to the next square number, and in this case, what's the next square number after 4? What did you say? What's the next square number after 1? No, 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 no. What's the next square number after? It's a 4. It's a 4. So try to divide 24 by 4 if it can. If it can't, then go to the next square number just like that. So divide 24 by 4. What is the answer? How many times can 4 go into 24? Anyone who can tell us? 6. So that means for me to get 24, I need to multiply 4 by 6. And then I can split these. So when you have got a product of numbers inside the root, I can say the root of 4 and then times the root of 6. The root of 4, we know that that's 2. So that is going to be 2 square root of 6. So this is the simplest form. So that is how we get to simplify these sides. Alright. So let's say we are talking about the square root of, let's say, 72. Want to simplify it. So let's divide by the smallest square number that we know. We can start first dividing by a 4. Can 4 go into 72? That's the question. How many times? Okay. So it can go there 18 times. So that means 72 is the same as square root of 4 times 18. But if you check again, 18 can also be split. 18 is the same as, there's a square number that you can take into 18. So you should make sure that you leave it in such a way that those numbers you get, there will be no square number that can go into them. So first I can say this is the same as 4, square root of 4 times square root of 18. And the square root of 4 is a 2. So this is going to be 2 square root of 18. But 18, what square number can go into 18? It's a 9. So that would be 9 times 2. And what's a, so I can also write this as 2 square root of 9 and then square root of 2. If I want, I can put a times or I can put a dot. All those mean multiplication mathematics. And the square root of 9 we know is a 3. So this is going to be 2, 3, and then square root of 2. So 2 times 3, that is a 6. So the answer is going to be 6 square root of 2. So that is how you get to simplify. Any question? Any question there? No. All right, good. Let's look at how do we add and subtract sides. Now, you can only add and subtract sides if the thing that is inside the radical is the same. Root of A plus root of B. This can't happen. This can't be added. Why? Because what is inside the root is different. But root of A minus root of A, these can be added or subtracted because what is inside the root is the same. So basically, when you are adding sides or subtracting sides, when you have got A root of B minus C root of B, the answer, since you can see what is inside there is the same, just get those which are outside. So it is just A minus C, and then you're going to have root of B. So just add what is outside or subtract what is outside. Or x root of A plus y root of A. The answer is going to be x plus y root of A. So this is how we add and subtract. So it's as simple as that. So if what is inside here is not the same, make sure that you make them the same. Otherwise, you can't add, you can't subtract that. Let's consider some examples. If we have got the square root of 12 minus the square root of 3, just a moment, I just tried to check something, and then plus the square root of 27. The question is evaluate. So how can we evaluate this one? The only way we can evaluate it is look at what is inside the radicals. Are they the same? No. So need to express them in the same form. So in this case, look at the smallest number which is given. The smallest number given is a 3. So make sure that you express everything in such a way that you are going to have a 3 inside. So what is the smallest square number that we can take into 12 without leaving a remainder? Say 4. So 12 is the same as 4 times 3. And then minus square root of 3. Then plus. What's the smallest square number that we can take into 27 without a remainder? Let's see. It's a 9.
9.
And then remainder. How many times can 9 go into 27? 3 times. So 27 is the same as 9 times 3. And then the square root of 4 is a 2. So this is going to be 2 root 3, then minus root 3 plus the square root of 9 is a 3. So that will be 3 root 3. And then to work this one out, just get what is outside. Here there is a 2. Here, though we can't see it, there is a 1. Here there is a 3. So I'm going to say 2 minus 1 plus 3. And then you just get root 3 like that. So 2 minus 1 is a 1. And then 1 plus a 3 is a 4. So the answer is 4 root 3. That's how you do it. Is it trick?
Yes, it is. Maybe you repeat a bit.
Okay. Anyone else apart from that? Anyone else?
So inside like those numbers where there's 2 minus 1 plus 3, when the other numbers, you don't use BODMAS, you just follow the arrangement that's there.
Yeah, you just go direct. Mm. So for the sake of our brother, let's look at another question that is going to cater also his question. Okay, so let's evaluate square root of 8. Let's say minus 8 square root of 18. Let's say plus square root of 32. Then I can have the last one minus, what can I even put there? Okay, and then minus square root of 128. So this is the question. Evaluate the square root of 8 minus square root of 18 plus square root of 32 minus square root of 128. So how can we do it? We need to make sure that what is inside the radical is the same. Now, what is the smallest? Of course, we don't look for the smallest. The question is, what should be the biggest square number that we can take into 8 without a remainder? We look for the biggest. But to simplify things, that's why I'm saying smallest, because if we say biggest, it might be a bit tricky. So what is the smallest square number that we can take into 8 without remainder?
Four.
Say 4. So 8 is the same as square root of 4 times 2. Then minus, what of 18? What's the smallest square number that we can take into 18 without a remainder?
9.
9. So that's 9 times 2. And then plus, in 32, what's the smallest square number that can go into 32? 15? 16? 16. But is 16 the smallest? It's the biggest, right? That's why I said we look for the biggest. But if we didn't know that 16 can go there, we can go for 4. We take into 4. The answer that we're going to get, 4 can still go there. So we'll go for 16 since we already know, and that is 16 times 2. Then minus. Now in 128, what square number can go there? In 128? Anyone? Okay. How many times can 4 go into 128? By the way, you will not be using calculators in mathematics, so you need to have the trick. So say 4 into 12, that's the 3 times.
32.
And then good, 4 into 8, that is 2 times. Well, 32 can still be divided by a square number. Let's say 4 again into 32. 4 into 32, how many times? Is it 8 times?
8. Mm-hmm.
And then 8 can still be divided by a 4. 4 into 8, 2. So we are seeing we have got 3 fours. And 4 times 4 times 4 times 4 times 4 times 4. That's a what? If you multiply 4 3 times, is this 64?
Yes. 64.
So we are saying for you to get 128, you need to multiply 64 by what? By 2. I hope we can get that. Okay, so we are saying this is 64 by 2. And then the square root of 4 is a 2, so that is going to be 2 root 2 minus square root of 9 is a 3, so that will be 3 root 2. Square root of 16 is a 4, that will be 4 root 2. And then square root of 64 is 8, so that will be 8 root 2. Now that we have got the same thing inside, then we can just get what is outside. The first thing is a 2, then we get a sign minus a 3 plus a 4 minus an 8, and then we just write a root 2 outside. What we are getting is this, this, and that. So 2 minus a 3 is a negative 1. Negative 1 plus 4 is a 3. And then 3 minus 8 is a negative 5. So that will be negative 5 root 2 as the answer. Any question?
Can you repeat here? This.
So you just get what is outside. As long as what is inside is the same, just be getting what is outside together with the sign.
As in how you end up with this.
The square root, how you end up with this, the square root of 4 is a 2. That's a 2 you can see here. And then this 2 still remains in the root because you don't have the you can't find the root of 2. Yeah, and then square root of 9 is a 3. And then the root of 2 will still remain. And then just like that. Do we have any question from anyone? Emma? Okay. Alright. So that's how you add and subtract. Now let's look at how we multiply, and then we are going to end with dividing because dividing is the most beautiful part of this one. So how do we multiply surds? Now the multiplication of surds is nice. When you can even multiply those which have not the same things inside, like the root of a multiplied by the root of b. So just get what is inside and then multiply them. So this is going to be the root of ab. That's how you multiply. Or if you've got a root x, and then no, let me put it like this: x root a multiplied by y root b. This is going to be these which are outside, multiply them alone. So x times y, and then you put root. Those which are inside, also multiply them alone, a times b. So this is how you multiply surds, as simple as it is. So you don't care whether what is inside is the same or not. So let's see how we will simplify something. So evaluate. When you've got square root of 2 minus 1 multiplied by square root of 3 plus 2 square root of 2. Let's work this one out. So just like we know from the algebra in high school that we did, distribute root 2 times root 3, that is going to give us root 6. And then the root 2 times negative 2 root 2. Remember, there is a 1 outside here, though we can't see it. So this one which is outside here will multiply with the negative 2 which is here. That is going to give us negative 2. And then this root 2 is going to multiply with this root 2. Remember, we just multiply what is inside. So that will give us root 4 because it will be 2 times 2. And then we come to this one. Negative 1 times root 3. That will be negative root 3. Then negative 1 times negative 2 root 2. That will be positive 2 root 2. Because this one is a constant, it will just multiply the number that is outside. So if you just have a 1, that one doesn't multiply what is inside. It will just multiply the number that is outside. So this is root 6 minus 2. Now, what's the square root of 4?
Two.
Say 2. So that would be 2 root 2 times 2. And then minus root 3 plus 2 root 2. So this would be root 6 minus 4 minus root 3 plus 2 root 2. This is going to be the answer. No, you can't go beyond that because you've got root 6, root 3, and root 2. There's no way you can add those or subtract those. So let's say another one. Express the following in the form a plus b root c. So this is the form that we want to express. And then the question is 1 minus 2, not, let me not use 1, let me use a 3 minus 2 root 5, and then multiplied by, that should be a 3 root 5, okay, minus a 2. So let's go on and work this one out. We want to express it in the form a plus b root c. First thing that we're going to do is we multiply 3 by 3 root 5. Remember, if this is a constant, it just multiplies the one which is outside. So that is going to be 3 times 3, which is a 9, and then you're going to have a root 5. And then this 3 will multiply with a negative 2, that will be a negative 6. And then negative 2 root 5 will multiply with this. So this negative 2 will multiply with the 3. That will give us what? Negative 6. And then the root 5 will multiply with the root 5. That will give us what? Root 25. But one thing that you need to know is that this is something that I think you've seen. Root a times root a is just a. When you multiply the same thing, just that thing which is inside will be the answer. Like root 5 times root 5 is 5. That is because we're going to get the root 25. And root of 25 is a 5. So I'll just put a 5 here. Negative 2 times 3 is a negative 6. And then root 5 times root 5 is a 5.
So you can get it true if you root 25.
If you want to put a 25, put a root there. And then now we can say negative 2 root 5 times negative 2. So the negative 2 here will just multiply with this negative 2. That will be positive 4. And then you have got a root 25, a root 5. And this will give us 9 root 5 minus 6 minus 30 plus 4 root 5. I'm going to put like terms together. So that is negative 6 minus 30 plus 9 root 5, then plus 4 root 5. Now negative 6 minus 30, that is negative 36. And then add these. Remember, when you're adding such, just add what is outside. 9 plus 4, that's a 13. And then root 5. So we have expressed in this form. So if the question was find the value of a, b, and c, this means that a is equal to negative 36, b is equal to 13, and then what is inside the root there, c, is equal to 5. Any question? Any question? Any question? Paxena, Msonda, Innocent? Anyone? Or is clear?
There on addition,
Mm.
we don't follow a board mass.
Uh, like here?
Mm.
Yes. Where? Or when you are just adding?
Mm.
You can follow it if there is need, but I've not seen anywhere where board mass is required. It doesn't matter whether you start with negative and then positive, or like we start with addition or subtraction. So those two you can swap them and nothing will be affected. So the same rules that we know apply. Board mass, we still use it when it is necessary to be used.
Okay.
Now let's look at division. the best part. Now on division, you need to know what is called rationalizing the denominator. So how to rationalize the denominator? That's the first thing that we are going to look at. So when you have got a surd, for example, 1 divided by the square root of a, your aim is to make sure that this is not a fraction. So to be able to do that, to take it away from being a fraction, the same thing that you can see in the denominator, multiply on top and down. So 1 times root a, that will just be root a. Now down, root a times root a is what? What is root a times root a?
Root a squared.
Yes, it is root a squared, and the square and the root cancel, so that's just a. So that's a. And you can see now we don't have a root in the denominator, so we've rationalized the denominator. That's what we call rationalizing the denominator. That's one thing that you do when you are dividing. And then the other thing, when you are dividing something that is in this form, maybe you have got a number on top, it can also be a side, and then divided by the root of a minus the root of b. It doesn't matter whether it is a minus here or it's a plus. So for this one, for you to be able to rationalize the denominator, what you do is the same thing that is down, write it on top, but change the sign. If it was minus, put a plus. If it was plus, put a minus. Write it on top and also down. And here what is going to happen is this. So it will be a multiplied by this. So that, let me just write as a open brackets root a plus root b. Now when from secondary school, I think we did the difference of two squares. How can you factorize a squared minus b squared? How do you factorize that? So it is a plus b, a minus b, if you've forgotten. Can we remember now? So same here. This is a minus b, this is a plus b. So when you are multiplying, it means it was a difference of two squares. So it is the same as root of a squared minus root of b squared. The root and the square cancel, the root and the square cancels. So in the denominator, just going to have a minus b. So whenever you multiply a number by its conjugate, just get that first number minus the second number. That's a general rule. But if you don't want to use a general rule, you can always get it. And how do you get it? Let's show. So what we have is root of a minus root of b multiplied by root of a plus root of b. These two. And we've already done how to multiply sides. So it will be root of a times root of a, which is just a. And then root of a times root of b. Remember, you multiply what is inside, so that will be positive root of ab. And then negative root of b times root of a, that will be negative, multiply what's inside, negative root of ab. Negative b times positive root of b, that will just be negative b, because what is inside is the same, they'll cancel out. This is positive, this is negative, they'll cancel out, so the answer just remains a minus b. So that is where it comes from. Any question?
I have a question.
Mm-hmm.
What do you mean? square root of a minus square root of b. How come this side is square root of a plus square root of b? This side they are plus plus, but down there it's a negative.
Okay, so what we are doing is we are rationalizing the denominator. When you've been given square root of a minus square root of b in the denominator, to rationalize, multiply by the same square root of a plus and square root of b, but just change the sign. So if it was here, then it becomes a plus. If it was a plus here, then it becomes a minus if you want to rationalize the denominator.
So it's a rule when the denominator it's negative, so every side becomes positive.
Yes, that's it. Mm-hmm. Yes, anything is possible anyway. So let's look at some questions. Evaluate. And what we want to evaluate is divided by square root of 4. Okay, so instead of proceeding from here, we're going to continue this